In today's lesson, we are going to talk about powers of numbers, which can also be called indices. And we're going to extend this, topic to exponential equations. So let's begin. We have no time to waste. All the questions that we're going to solve are, BEC past questions from 1990 to 2026. We have 2 exponent 2, 2 exponent 2 times, 3 exponent 2 times, 2 exponent 3 times, 3 exponent 4. So how do we multiply this stuff? To be successful in indices, you have to know the laws of indices or the laws of exponents. Now, this is multiplication of indices. So which law are we going to use to, simplify this stuff? And what is the law saying? Now, the basis must be the same before we can multiply. So, for example, if you have, let's say, a exponent 2, we can multiply because the bases are the same. These are the bases and this is the exponents. These are the exponents. So when it comes to this one too, we have to make sure they have the same basis. But as you can see, the bases are alternating, from 2 and 3. So you have 2, 3, 2, 3. So we have to rearrange in such a way that it's going to be like this: 2 exponent 2 times this one. That is 2 exponent 3 times 3 exponent 2 times 3 exponent 4. Now, what's the law saying? If the bases are the same and they are multiplying, we take one of the bases. So in this case, we're going to take, 2, then we add the exponent. So that's going to be 2 plus 3. That will give me 5 times 3 exponent 2 times 3 exponent 4. We take one of the bases, then we add the exponent. So we have 2 plus 4. That's going to be 6. So easily and simply, we have been able to multiply using the law of indices for multiplication. Now let's take the next question. We have 3 exponent 9 divided by 3 exponent 3. So this time we are dividing. So we have to use the law for division. The law is saying that for division, we take one of the bases as well, but this time we are not going to add the exponent, we subtract. Now, so that's going to be 9 minus 3. So we're going to get 3 exponent 6. So that is that for that one. That's very, very simple. So let's take our next question. We have 6p cubed times p squared divided by 3p exponent 4. Now, how do we simplify this stuff? Now, we can multiply this, then we divide by this. So now let's multiply. Since the bases are the same, we can multiply. And what do? We're just going to take one of the bases, then we add an exponent. So we have 3 plus 2. So if you want to show workings, let me do that here. Now divided by, 3p exponent 4. So this is going to be 6p exponent 5 divided by 3p exponent 4. So at this point, 6 divided by 3, that's going to give me, 2. And now this p exponent 5, p exponent 4, remember we are divided. We take one of the bases, then we subtract the powers according to the law for division. So that's going to be 5 minus 4. So I'm going to get 2p, exponent 1, which is the same as, 2p. They are all the same. Now when you get to this point, 6p exponent 5 divided by 3p exponent 4, we can rewrite the expression as this. So we have 6p exponent 5 divided by 3p exponent 4. If you don't want, this approach, you can do it like this. Then we're going to get the same answer. Now 3 goes into itself 1, it goes into 6 2. So we have 2 here. And this one, we have p exponent 5, p exponent 4. We use the one with the smallest exponent to cancel this one. So p exponent 4 here 1, it goes into this one, p times. So that is, the indirect way of subtracting the exponent. So we have p. So we have 2p. So we are going to get the same answer. Let's move on to the next question. We have bracket of 2 exponent 6 times 3 exponent 4 divided by bracket of 2 exponent 4 times 3 exponent 2. How do we simplify the steps to? In the various brackets, the exponents, the bases are not the same. So we can't multiply them unless we change them to the normal form, which will make the work, difficult or more difficult. So what am I going to do? I'm going to write this in a different form. So that's going to be 2 exponent 6 times 3 exponent 4. Now all over, 2 exponent 4 times 3 exponent 2. So what I've just, done here is the same as this one. In fact, nothing has changed. The same as this expression. So we have 2 exponent 6 times 3 exponent 4, or divided by 2 exponent 4 times 3 exponent 2. So I can do cancellation direct, but if you don't want to do that, you can do it like this. So we have, bracket of 2 exponent 6. That means I'm taking, those with the same, base. So you have 2 exponent 6 divided by 2 exponent 4. Now, times, this is the multiplication. So times bracket of 3 exponent 4 divided by 3 exponent 2. So I've just separated them. And this is what I'm going to get. We have 2 exponent 6 minus 4 times, 3 exponent 4 minus 2. And I hope you're not confused. We are just subtracting the exponents. So you have 2 exponent 2 times 3 exponent 2. Let me get my 2 well. So that is how we can simplify this stuff. So that's the final answer. Let's move on to the next question. So our next question is bracket of 8x squared y exponent 3 bracket of 3 on 8x y exponent 4. So this expression, now anytime we know that two brackets are facing each other, it means they are multiplying. So it means we have 8x exponent 2 y exponent 3 multiplying the whole of this stuff. So you have 3 on 8x y exponent 4. Now this is multiplication. We can just multiply the numbers, then we multiply the letters. Now separately, you know that 8 times 3 on 8, this 8 can cancel this one. So we can do that here. So now 8 goes into ECF1, it can go into this 8 1. So we are done with this. Now we can multiply. We have x squared y cubed times 3xy exponent 4. So now let's multiply. We are going to get 3. You see, 3 times this one, there's no number here, so we take it to be 1. So 3 times 1, we're going to get 3. So you have 3x. We multiply the x squared by this x. So that's going to be x cubed. And I hope you're not confused. We have just added the exponent. This one has an exponent of 1. And now this is going to be y exponent 7. That is 3 plus 4. So that is it. So remember that when we are multiplying and the base are the same, we add the exponents. But when we are dividing and the base are the same, we subtract the exponents. So that's the answer to this question. Very, very simple. Let's move on to the next question. So we have to simplify 16 squared times 8 squared. How do we simplify this one? This time the bases are not the same. This is 8, this is 16. So what do? We can't apply the law of indices for multiplication here because the bases are not the same. So we have to, express these numbers in such a way that they have the same basis. Which number are we going to use here? That we can express 16 in terms of that, and that of 8 in terms of the same number. And obviously, the number is going to be, 2. So we have 2 exponent 4 will give you 16. 2 exponent 4, 2 exponent 4 will give you 16. But remember that the 16 already had, 2 as an exponent. So that's going to be 2 exponent 4 raised to the power 2. Now, times, let's talk about this 8. And that's going to be 2, 2 exponent 3. This one too has, exponent 2 already. So we have 2 exponents at the same time. Now, what do? The base are the same, but we have to simplify this stuff. The exponent. There is a law for this one. We call it the power rule. That is when we have 2 powers. And what happens to the powers? We multiply them. So let's multiply the exponents. So we're going to get 2 exponent, 8. That is 2 by 4. Now times this one too, we have 2 exponent 6. That is 3 by 2. So now everything is set. To take one of the bases, then we add the exponent. So we have 8 plus 6, and that will give us 2 exponent 14. So that is how we can simplify this stuff. So remember the power rule. Let's move on to the next question. We have 5 exponent 7 times 5 exponent 4, all divided by 5 exponent 2. So how do we simplify this stuff too? So it is very, very simple. We just have to do cancellations here if you want us to do that. Now, 5 exponent 2 here is 1. It goes into this one, 5 exponent 2. And the reason is simple. Remember, we are dividing. So we have just subtracted the exponent. So we have 5 exponent 2. So now the whole of this stuff is going to be 5 exponent 7 times 5 exponent 2. We don't have over 1 again because over 1 is the same as this one. So at this point, we have the same basis. We just take one of the bases, then we add the exponent. 7 plus 2, that's going to be 9. So that's the answer. Very, very simple. Let's move on to the next question. We have 2 exponent 2 times 3 exponent 2 all over 4 exponent 2 times 3 exponent 3. You have to simplify this stuff too. Now let's make sure they have the same basis. I'm talking about this and that. This is 4. So with this one, we have 3, we have 3. But we can do something about this one. So I'm going to express this 4 in terms of 2. So the new expression is going to be, 2 exponent 2 times 3 exponent 2 all over, let's express 4 in terms of 2. And that's going to be 2 exponent 2. Remember, we have 2 here already. So that's going to be exponent another 2. Now times 3 exponent 3. So at this point, what do we do? I'm going to get 2 exponent 2 times 3 exponent 2 all over. And according to the power rule, when we have 2 powers, we multiply the powers. So that's going to be 2 exponent 4. That is 2 times 2 by 3 exponent 3. So let's simplify. So I'm going to use, this approach of cancelling or doing cancellations. Remember that we always use the one with the smallest, exponent to cancel the one with the biggest exponent. So in this case, we are not going to use the denominator to cancel the numerator, but rather the vice versa. So 2 exponent 2 here, 1, it goes into this one, 2 exponent 2. And 3 exponent 2 here, 1, it goes into this one, 3 exponent 1, which is the same as, 3. So I'm going to get 1 times 1, which is the same as 1, all over 2 exponent 2 times 3. Let's move on to the next question. We have 27 exponent m plus 1 all over 3 exponent m plus 2. So that's an interesting, stuff. And how do we simplify this stuff too? Remember that exponent is a binomial, that is m plus 1, and this is m plus 2. But we have to make sure they have the same basis. This is 27, this is 3. So what do? We can express 27 in terms of 3. And that's going to be, 3 exponent, 3. Because 3 exponent 3 will give us 27. And now, remember that this 27 already had, m plus 1 as an exponent. So we have raised to the power m plus 1. Now, all over, we have 3 exponent m plus 2. So, according to the power rule or law, we have to multiply the exponent. That's the power rule. So, I'm going to get 3 exponents. This 3 must multiply m plus 1. Remember, m plus 1 is a binomial. So, that's going to be 3 into brackets m plus 1, if I'm to break it down for you to see. So, now we have 3 exponents m plus 2. So, let's do the stuff here. You're going to get 3 exponents 3m plus 3. That is 3 times m plus 3 times 1 all over 3 exponents m plus 2. So at this point, they have the same, basis. That's 3, 3. So we can add, we can subtract their exponent according to the law for division. So we take one of the bases, which is 3, then we subtract their exponent. So that's going to be 3m plus 3 minus, m plus 2. So let's simplify this stuff. So that's going to be 3 exponent 3m minus m plus 3 minus 2. I hope you're not confused. You see, this minus is affecting the m and the 2. So finally, our answer is going to be 3 exponent 2m, that is 3m minus m plus 1. That's an interesting question. So that is how we can simplify this stuff. Let's take another question. We have 36 a cubed times b squared x. This is not nice. Let me get a better x times x out over, we have 27 a b cubed y, and we have to simplify this stuff. Let's go about this one. So you have 36, 27. How do we simplify 36 and 27? I mean, 9 can go into these numbers. So 9 goes into 36 4 times. It goes into 27 3 times. Now with this, a cube and a, we can apply the laws of indices here easily. We can do calculations. This one has an exponent 1, so we can use this one to cancel this. We have a here 1. It goes into this one, a exponent 2. That is a cube divided by a. So that's going to be a exponent 3 minus 1, and that is going to be a exponent 2. So that's what we have here. Now we have b exponent 2 over b exponent 3. So are we going to use b exponent 3 to cancel b exponent 2 or vice versa? So obviously, I'm going to use the one with the smallest exponent to cancel the one with the biggest exponent. So that means b exponent 1 here, 1, goes into this one, b. And now we have x and y, which we cannot simplify. So at this point, we have 4 a squared x over 3, b, y. This is how we can simplify. We can't do anything about this expression again. So that's the final answer. Let's get another question solved, still on the indices. So very soon, I will turn the attention to, exponential equations, and we see how we can simplify those stuff too. So this is going to be our last question on the powers of numbers. So we have 35 x exponent 5 y exponent 3 divided by 7x y exponent 2. So we can write this one in this form, in this form. So that's going to be 35 x exponent 5 y exponent 3 out over 7x y exponent 2. So what do? We do cancellations. So let's cancel out. We have 7 and 35. 7 goes into itself 1, it goes into 35 5 times. We have x here, this is x exponent 5. So I can use this x to cancel itself, and it goes into this one how many times? That is x exponent 4. We have y exponent 2, y exponent 3. We can use this one to cancel itself, and it goes into this one, y exponent 1, which is the same as y. So we can see that the whole of the denominator has turned into 1. So you're going to get 5x exponent 4 y all over 1, which is the same as 5x exponent 4 y. So at this point, let's turn the attention to exponential equations.